Okay, this is 2.3, the second day, so we're talking about notes here. Basically, taking notes and examples on what you did in your graphing assignment. In your graphing assignment, you learnt about translations and transformations. We're going to talk about that now and kind of consolidate some of that learning. So you have a section there that we're going to take notes in. You're going to want to write fairly small, not teensy tiny or anything, but don't waste space where those two little graphs are to the right. First note, transformation.
Does this stuff have to be in a different color?
Nope, this is just notes. Transformation. This is a change made to a figure. A figure is a special word for a shape. A change made to a figure or a relation. That's where we get involved because functions are relations. So transformation is a change made to a figure or a relation, which is a function, could be a function, so that, or let's say a change made to a figure or relation that changes its shape or position. So it can change the shape or it can just move that shape around. There are a few different types of transformations. In order, we talk about them as stretches / compressions. So you can either stretch a shape or compress a shape. You can reflect it, reflections. So you can flip it over an axis of some sort. In our case, we'll be talking about the x-axis, flipping it over the x-axis. You can also take a function and flip it over the y-axis, but that looks a little bit different. And you can perform a translation. So the types of transformations are stretch or compression, reflections, and translations. Well, what is a translation then? Because that's what we're mostly talking about today. Translation results in a shift of the original figure or graph without changing the shape. So a translation is just going to move it around. Transformation can change the shape, flip it, and move it around. Translation is just a specific type of transformation, and all it does is move it around. It either moves it left and right and left, or up or down. Okay? The pictures of the graphs that you have there is where we're going to just put some examples of transformations, translations that can happen. So I'm going to draw a graph. I'm going to draw mine on the left, just so I don't smudge marker all over my hand. I'm going to assume a function.
So are we drawing this?
You can draw this, okay? This blue one is f of x. Okay, you can see it clearly looks like x squared. But there's a couple of different things that can happen to this graph. It can either be translated up or it can be translated down. Very good. Okay, I'm going to draw up first. So let's say I take this exact parabola, this exact same shape as f of x, and all I do is add to it. Let me see if I can draw one that's same as possible.
Still blue?
That's pretty good. No, I'm using a different color.
Looks like the same color.
This purple one is f of x plus c. What does that mean? That means all I did to move my blue function up is add a constant. Constant being just a number without a variable. Okay? If you have a function and you add something to it, just a value, just a number, a known number, all it's going to do is move it up. Okay? You're going to see examples of that as we move along, but just a very quick example. If you had y equals x squared, you don't need to write this, but if you had y equals x squared, which is kind of what f of x looks like, and you added 7, all it would do is move it up 7. Okay? What else could happen? It could move down. Hello.
Another color.
Okay, tried to keep the exact same shape as my blue function. This is now f of x minus c. Oh, if you add a number, it moves up. If you subtract a number, it moves down. Mr. V, can you put that in writing for me so that I never forget it in my whole life? Sure. This guy is a translation of f of x up c units, where c is just a number. 1 unit, 2 units, 7 units. If it's f of x plus c, it's a translation up so many units. Okay? What about this one? This is a translation of f of x down c units. That's pretty straightforward, right?
Yes,
If
sir.
c is positive, the graph moves up. If c is negative, the graph moves down. This is vertical translations, okay? Vertical translation, up or down. On the next graph, you guessed it,
Horizontal.
horizontal translations. We're going to start with something that looks like x squared, and we're going to call it f of x. And then what I'm going to do is draw 2 others. I'm going to take my purple color here. I'm going to draw a graph. I'm going to try to give it the exact same shape as my blue one. That's not very good. It's quite a bit bigger. That's too bad. But hopefully you can still see. I'm going to call that
How unfortunate.
f of, and watch this. This time we, up here for vertical, we took the function and added or subtracted c from the function. This time we're going to add or subtract a value from x.
Why?
So it's f of x minus d. Okay, that's a standard kind of form. And in this case, d is greater than 0. Okay, what does that mean? The standard form is x minus d. So you're probably having flashbacks to vertex form here, where you have a x minus h squared plus d. But anyway, this is inside the bracket with the x. You're subtracting d, and d is positive. So these brackets are going to look something like, you know, x minus 2, or you don't have to write this, x minus 7, or x minus 3 halves. Okay? All of these things, d is positive. Mr. V, there's a negative sign there. I know. It's x minus d. It's x minus d. So for there to say x minus 2, then d must be 2, which is positive. Positive 2. Here d is 7. Here d is 3 halves. Okay? What happens when d is positive? Well, the graph moves to the right. Okay, I'm going to finish that off. Sorry for erasing it by accident. This is a horizontal translation d units right. You can clearly see that my blue graph moved to the right when it became purple. Alright, we're going to do this again. I'm going to try to draw the exact same shape. It's a little better than my purple one. The red guy here now is f of, watch this, it's still x minus d, but this time d is less than 0. Okay, what does that look like? That would look like x, oh, look at that, plus 2. Oh, that would be an example of d being less than than 0. Mr. V, that's really confusing. Does that mean we switch the signs? No, you don't switch the signs. It's x minus d. So this is x minus negative 2. Clearly d is negative 2, which is less than 0, which is going to cause a horizontal translation d units left. So yes, if you see a positive something, a plus something with the x, d is actually negative, and it's going to move to the left. And if you see a negative symbol in there, like this, x minus 4, then d is actually positive, and it's going to move to the right. Okay, backtracking just momentarily because I added a word here, right, and I didn't add it here. I should have said this is a vertical translation, f of x up c units, and this is a vertical translation, f of x down c units. All right, those are the only opportunities for translation. Question, could there be vertical translation and horizontal translation in the same question?
Yes.
Yeah, for sure. You just put something in with the x in the brackets, and if it had something at the end, then it would be poof. Vertical and horizontal translations. Really easy example of that. This is a quadratic. It's a parabola. Has a vertex. The vertex is at HK, which means that this vertex could move left and right and up and down and end up somewhere over here. Whoop, 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 whoop. Or over here. Whoop, 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 whoop. Yeah? Get it? Got it? Excellent. Okay, in example 1, we are taking a function. In the case of A, it's just kind of a random function. In the case of B, it looks like a root function. Anyway, we're taking a function and we're going to translate it. In order to do that, we're going to use something called image points. We're going to determine image points, okay? What is an image point? Image point, little definition in the space that you have there, maybe at the very bottom or else just above the example. Not sure where you want to put it, but here you go. Image point. It is any point that has been transformed. That has been transformed. So if you have a point on the graph, I would usually call it like a key point, and then you transform it, you move that around, or you stretch and compress or reflect based on that point, then the new point that you've created is called an image point. So every key point has an image point, is basically the point. Any point that has been transformed from a point on the original function, on the original graph, let's say. Any point that has been transformed from a point on the original graph. So in A there, you guys have a graph that looks like this, and you're going to have to go ahead and just listen carefully. You're going to put the point A at -3, +1. You're going to put the point B at -2, -2. You're going to put the point C at 1, -1. And you're going to put the point D at 3, -1. And then you're going to connect those dots with a nice straight line.
Connect the
A,
dots.
B, C, D.
Borger with connect the dots. The best.
Okay? So you have a function. This function is f of x. So go ahead and do f of x. And we are asked to draw g of x, which is f of x plus 4. Well, hopefully you're pretty quick and savvy and you have figured out what to do with each of these key points, A, B, C, D. You're going to create an image point for each of them. How are you going to create an image point? Well, for every key point on the graph of f of x, you're going to
Add 4.
Move it.
4 to the right.
Nope.
4 up.
Nope.
How do you know if it's 4 to
Up
the right?
4. Thank you very much. Because this is f of x plus c. Go ahead and flick back to your notes to confirm. Up, down, left, right. Meh, up. Okay? So 1, 2, 3, 4. I'm not going to do a super great job, but there's my image point A, and I'm going to call that A prime. Okay? B is going to go 1, 2, 3, 4, and I'm going to call it B prime.
Well, it's gonna get messy.
C is going to go 1, 2, 3, 4. I'm going to call it C prime. D is going to go up 1, 2, 3, 4. And I'm going to call it D prime. Connect the dots. And yours will look much nicer than mine, but you should have the exact same shape. It shouldn't look different at all, except that it's been moved up. This graph is now g of x. And the only thing that's changed is all of my y coordinates have gone up by 4. Okay? So listen, pay attention very carefully. We're going to make a little diagram so that you can get this. We're looking at f of x. Okay, and I'm going to give the coordinates of f of x. Okay? What does that mean? That means every point on f of x, which is our black one here, a, b, c, d, is represented by coordinates because they are at a location on the Cartesian grid or on the plane, however you want to say it. A
Are they equivalent?
is at -3, 1. B is at -3, sorry, -2, -2.
Just watch
You can watch if you want. I won't do this for the next one. C is at 1, -1. D is at 3, -1. Now, on the next side, I'm going to do the coordinates for g of x. Okay? The coordinates for g of x are x, and then what did we do? We did f of x plus 4. Okay? Now, that means x is the same. Did this thing move left to right at all? No. So my a and a prime actually have the exact same x coordinate. But the y coordinate, which is the second coordinate in your ordered pair here, is the same as f of x, but add 4. So 1 plus 4 is 5. That is my new image point. That means this is -3 plus 5. Okay? Here, for b, b prime, and I'm going to name these a prime, b prime. The x coordinate has not changed. The y coordinate is going to go up 4, and -2 plus 4 is 2. Okay? So right here on my graph, if I'm drawing this in, I have -2, 2. C prime. My x coordinate does not change. My y coordinate is going to be -1 plus 4, which is 3. That gives me the location of C prime. 1, 3. D prime is 3. And then to my y coordinate, I add 4. I get 3, 3. D prime, 3, 3. And there I have the coordinates of my image points on my new function, g of x. Make sense?
Yep.
Okay? All this little prime says is image. This is A, this is the image of A. This is B, this is the image of B. C, image of C, D, image of D. Good?
Are
Good.
they equivalent or no? Like the line?
Are these equivalent functions?
Yes.
No, they are
No.
not the same. The value that you get when you put something into f of x is not the same as the value that you get when you put something into g of x. Okay? They just look similar, but they have been translated. Okay? It's the same shape, but it's been moved around.
Transform.
For example 1b, I'm going to give you the picture of the relation that we're starting with. It looks like this, but hold on. It goes through A, which is obviously 0, 0. It goes through B, which is 1, 1. It goes through C, which is 4, 2. Does anyone know what the next point is going to be?
8, 4.
16,
Nope.
nope.
8.
No.
64.
It is going to be 9, 3. Okay, if 9, 3 doesn't fit on yours, A, B, C, D, that's okay.
It does.
No, it doesn't.
The transformation that you're
Yeah.
going to draw, so this is f of x. What I've given you is f of x. Doesn't matter what the function is, it's just f of x is this picture. And you are going to draw g of x, which is going to be f of, pay attention, x plus 4. This time it's a lot easier to see. You're literally adding 4 to the value of x. Okay, that is the transformation. It's going to move horizontally because you're adding a value, you're adding something to x before you put it into the function even.
So adding 4 to x.
Correct.
Except, Mr. B, shouldn't...
Oh, sorry,
Yeah,
we're not adding 4 to
That's what I
x.
was about to say.
Good job.
Oh, did that count as a mistake?
Because it's f of x minus d, then here we actually have the case where d is equal to negative 4, which is going to move it which way?
Still right.
To the right.
No, d. That's what the whole that we just did. D is negative 4. It's going to move it left.
Kidding.
Okay, good.
BX minus
So
4.
all of these go 1, 2, 3, 4. A prime is way back here now at negative 4, 0.
We don't have that.
It's fine.
Just draw it in.
I don't have room to plug in. There's nowhere to. Can I use your ruler actually? What?
This is like the least confusing thing we've done so far.
I know, it's so easy.
What is it? She busy trying to draw my line.
Compared to everything else we've done.
Oh, sir. What did that accomplish?
You got the image of G of X, I think.
Why not here?
Okay, we could do a table of values to show that only the x-coordinate is changing and the y-coordinate stays the same for each key point and its image point, but you can kind of see it right there if you look at them together. What's the point? You've just done a little bit of practice on taking a figure and translating it either up or down or left or right based on the information that it gave you. It said take f of x. In the first one, take f of x and add 4, so move it up 4. In this case, add 4 to x before putting it into the function, so d is negative 4, means you're moving it left. Every key point is going to move to create an image point, and then you sketch your graph that way. Example 2 is all about describing transformations. So we're going to start with a base function, or what's called a parent function. Every type of function has a parent function. So a quadratic, the parent function is x squared. That's the most simple power function for a quadratic. If we had a cubic, the parent function would be x cubed. Okay? So for instance, this function, let's call it h of x. H of x equals 2x minus 2 squared plus 1. Don't write any of this, but this is still a quadratic. It's a parabola. It forms a parabola, just like this one forms a parabola. This is the parent. We can talk about this function. We can talk about the transformations that have happened from this original parent function. What's happened? Well, there's a stretch compression factor, a stretch factor of 2. It's moved left or right 2 units, and it's moved up or down 1 unit. Okay, we have to decide. We'd have to work through it and figure out what it is. This is moving right 2 units and up 1 unit. That is a transformation of x squared. So I always talk about things in terms of its most basic function, which in the case of quadratics is x squared. So example 2. Number 1, we are taking functions that they give us. A is the function g of x, which equals x plus 5 squared plus 1. And it is a quadratic. So its base function is what?
Oh, f
Y
of x
equals x
equals x squared.
Base function is f of x equals x squared. Okay, well, let's talk about its translations, transformations, and then we'll write down some of the parameters that we know. Basically, this is what we've been talking about, okay? So this is, I'm just going to write our basic thing here. We've got a x minus d squared plus c, okay? We're not worrying about a right now. That's a stretch compression. We're not doing that today. But we do have some information here. What do we have? Okay, yeah, let's work left to right. So let's talk about this guy first. What's the value of d? Be very careful. Don't call it out.
Negative.
Yep, no, go ahead.
-5.
-5.
Don't call it
Okay,
okay.
x minus -5. So here, d equals -5.
What is D?
What is that going to? It's just a parameter. It's just a number that we put in place. It's just a letter that we put in place of a number. It means it could be any number, and we have to figure it out, but they've just told us that it's -5. The real question for this example is, what does it do?
It moves it horizontally.
Horizontal,
No, C does.
No.
trans, proper language, horizontal translation, what?
To
5 times to the left.
5 units left. The other parameter that we have in our example is C,
-1. Or +1.
positive 1. C is 1, which does what?
Moves it.
Not moves it.
Yeah.
vertically translate.
Vertical. I'm going to make you use that language, so get used to it. Vertical translation, 1 unit up. All right. So if we're going to sketch this thing, which you are going to do you have little graphs on the side or no?
No.
Okay, so we're going to sketch this. The easiest way to sketch this is to start with, it's in vertex form, which is really helpful. So I'm going to go ahead and sketch the original, the basic parent function, which looks like this. Okay, this is f of x equals x squared. And since this is given in vertex form, we basically know that this vertex is going to move. Let's just, like this curve is infinite number of points, but one point that's really easy to identify is the vertex.
0.
Okay, so every single point is going to move left 5, up 1. But the one point that we actually have here is the vertex. So I'm going to move it left 5, up 1. There it is. Okay, what did we do? We moved it left 5, up 1. And now from there, you draw the exact same curve. It hasn't changed shape because there's no stretch, compression, reflection. And you try to draw the exact same shape. Now, to do an even better job, you could take a couple other points. If you see that you're on a nice grid and it's going through a couple other points, you can just move each of those points left 5, up 1. Okay, that will help you draw it. This is g of x. We always label our graphs. G of x is, in brackets, x plus 5, close bracket, squared, plus 1. Okay? All right, the other thing that we're going to do in this example is note the domain and range. The domain and range. Domain first. Maybe I'll write it domain. Are we talking about x's or y's when we're talking about domain? Is that the things going into the function or things coming out of the function? Going in. Okay, so any x values that... Yeah, it's the input. Thanks. Any restrictions on the domain? Are there any values of x that I'm not allowed to put in this function? I can put anything in. X belongs to the set of real numbers, no restrictions. Now, when I put my infinite number of x's in, are there any values of y that are just simply not going to come out of this function?
Any negatives?
Nothing negative. Let's get more specific.
Probably like -1.
Where's your vertex, folks?
No positives.
Where's the vertex?
-5, 1.
1, right? The value of the function at the vertex is the y coordinate. We're talking about y's, right? So y belongs to the set of real numbers. But The lowest y value in my whole red function is 1. So y can't be less than 1. There's simply no function down here in the land where y is less than 1. So y is greater than or equal to 1. Really helpful point. Parabola, the domain of a parabola will never have restrictions. Okay, unless you've done some algebra and factors have canceled out, which we did a couple days ago. But generally speaking, a parabola like this, you can put anything, any value of x can go into it.
Because it can go anywhere.
It will, because it can go infinitely to the right, infinitely to the left. It will keep on, as it grows up, it's going infinitely left, infinitely right, vice versa. Okay, but will it ever go down?
No.
No. Okay, its
Can't go
minimum value is 1.
where
So
we find
y
the
is greater than or equal to 1. Okay, b is a function you're not as familiar with. B is g of x equals 1 over x plus 3 minus 7. This is a rational function. Okay, this is a rational function because it has a fraction with the variable in the denominator. The base function, if you could choose from your options, what would you choose? You have the options on your sheet.
Do we?
X equals X.
No, fx equals
1
1
over
over
X.
x.
I didn't even know we had that.
F of x equals 1 over x. Very good. That is the base function, and now we're going to see what happens to those things. So pay attention, because we're going to write this, we're going to write in function notation and then using words. So listen, this is going to seem confusing, but g of x is this right here. So I'm going to write g of x. And what is happening to g of x? Well, I see that my parent function is 1 over x. But now I have 1 over x plus 3. So what's actually happened is when I see f of x, wherever I see an x, we actually put in what? X plus 3.
No.
Okay, and then I have this function. So I've applied one of my transformations. I have, everywhere I see an x, I'm going to put in x plus 3. And then I have, this is the shape of it. It's all done there. But something else is happening to the function. I'm going to subtract 7. Okay,
So,
making a little note for ourselves. And this is going to be somewhat new, but somewhat making a connection. We have x minus d plus c. Okay, so you still have those same two parameters. You have a vertical translation and a horizontal translation. Let's talk about them. What do you see? What is the value of d?
-3.
D is -3. What is that going to do? Proper language?
Horizontal
Translation.
-3.
Left.
Horizontal
-3.
translation,
Not negative
3 units
But
left.
it's negative.
But you don't say negative
Why
3
don't
units
you just
left.
say 3
If you say
Okay, the other parameter is c. What's the value of c?
It is -7.
What does it do?
7 vertical translation.
1 unit.
negative
7
7
units
units
down.
down.
Vertical translation, 7 units down. Now, do you know what this function looks like?
Yes.
No, you don't really know what this type of function looks like because you don't know what the parent function looks like, or at least you're not super familiar with it. But if you did know what it looked like, you would be able to draw it because you know exactly how it has moved. Okay? So I'm going to give you what the parent function looks like. Okay, drawing it down here. You can find a nice place to draw yours. The parent function, which I'm going to do in blue, goes through 1, 1. So this is how I draw my rational functions. It goes through 1, 1, and it goes infinitely up. There's an asymptote there, and it goes like that infinitely. So it goes up. It also goes through -1, -1, and that negative quadrant 3 leg looks exactly the same. Okay,
Unblocked.
that is the parent function f of x equals 1 over x.
Why is it so weird?
Now all we need to do is take our key points, well really every point along the curve, and we need to move it left 3, down 7. Watch the easiest way to do that. Can you see how this line, my x-axis, is actually quite special with regard to this function?
They
It's
never
an,
touch.
it's an asymptote. The curve gets closer and closer and closer to that line but never touches it. Well, watch. If all I need to do, if this function is moving down 7, I just need to move that asymptote down 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to do a dotted line for
Over 3.
my new asymptote. Okay, that's now the line x equals -7. Sorry, y equals -7. And it's moving vertically left 3. How do I move every single point on this two-legged curve left 3? I'll just move the asymptote left 3. 1, 2, 3. The original function had a dot at 1, 1, kind of nestled in the corner here. So my new function, since it's not changing its shape at all, it's just changing its location, it's going to have that same key point, kind of 1 in, 1 up. And then
Oh my
the
god.
curve is going to do the exact same thing. Because it hasn't changed shape, it's just changed location.
I see.
And our new curve also has a dot kind of nestled in here, just like our original one had a dot nestled at -1, -1 in quadrant 3 there. We're going to have the same dot, and it's going to do the same thing.
Never gonna touch.
Oh, I understand now.
Yeah.
I
So
didn't see.
basically, you just moved the whole.
He moved the graph.
We
over.
moved the whole thing. That's all we did. We translated it down 7 and left 3.
A measure.
And this is g of x, which is 1 over x plus 3 minus 7.
I complain.
Let's talk about the domain and range. Okay, the domain and range. We're going to talk about the domain and range in this case of the original and of the new graph. Okay, so the domain and range, I'm going to do my original in blue. Okay, so for f of x equals 1 over x. Domain, range. Are there any restrictions? Trying now to get your brain to look at just the blue curve, just the original curve. Is there anything that x is not allowed to be?
It can't go into the negatives on y or x.
Well, what about this whole blue leg?
Yeah, why is there 2?
Hmm,
How is that one line?
it's not one line, it's one function, it's one curve.
Can't
So-
be 1? Or
Can't be 0.
Can't be 0. Can't be 0, okay? So the axes are at 0. So the y-axis is at x equals 0, and the x-axis is at y equals 0.
The asymptote.
Okay, so the domain, what values of x can't go in, or you could just look here and say, well, x can't be 0 because the denominator can never be 0, right?
Big brain.
So x belongs to a set of real numbers such that x cannot be 0. What about the range? Range is easier to get by looking at the graph. It's the same. Y can't be 0. Here's all infinitely positive y's, and here's infinitely negative y's, and it can get closer, 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 closer to the line y equals 0, and closer on this side to y equals 0, but it'll never touch it.
That's
So
x
y
equals 0.
belongs, nope, it's not.
No, it's one.
Y belongs to a set of real numbers. Y cannot be 0. That's the original.
So y and x are both asymptotes?
For the blue one, the original function, yeah, the axes are both asymptotes, a vertical asymptote and a horizontal asymptote. Okay, for our transformed function, g of x, which is 1 over x plus 3 minus 7, the domain, well, if I moved all of the points of the function, thinking about domain, if I moved all of the points of the function to the left 3, then I probably moved the asymptotes to the left 3 as well, didn't I? So now our asymptote our
-3.
vertical asymptote, which is a restriction to the domain, is -3. Can't be -3, right? So x comes from the set of real numbers such that x cannot be -3. Go ahead and do the range. You could look at the graph and start all over in your thinking, or you could just say, oh, what did we do to the y values of this function? Well, we moved them all down 7. So that means I moved that asymptote down 7 as well. So y can't be -7.
I don't have much room left.
In C, the g of x that we're given to work with is radical sign x minus 2, and then outside of the radical we're adding 4. Okay, what is the parent function or the base function?
F of x equals
X square root
Look at him
x.
try so hard.
Base function f of x equals radical x or square root of x. Okay, that means whatever x you put into it, you're going to square root it. So not square it, you're going to square root it, and that's what's going to come out. So what's happening here? Well, g of x then, I'm going to do it in red. G of x says take f of x, but everywhere you see an x, what does that x become? What's going to happen to the x before you perform
Add
the square root?
-2.
You're going to subtract 2. So you got x minus 2. And then after you're done that and
Add
you
4.
square root it, you're going to add 4. Which gives us our parameters, d, okay, which if I do, let's say g of x is f of x minus d plus c. Okay, you're getting used to this. You can either move things left to right, or you can move things up and down. So you're always going to be referring to this thing. Okay, so what is d? The value of d? Careful, don't call it out unless you know it for sure.
It is -2. Horizontal translation. 2 units left.
Close.
Students, right? Right. Don't call it down.
Horizontal
And then
translation, 2 units, right.
Boy.
The other parameter is c, which is the, what's the value?
4.
4, which means
Vertical
Translation 4 units
up.
well, you guys are cool.
vertical translation, 4 units,
They said it so
Up.
monotone because they thought they're cool.
and let's sketch it.
Only math was that cool.
Okay, square root function looks like this. I'm just going to draw it and then put my key points in. It has key points at, I'm not even going to list them, but it has 0, 0, and then 1, 1, and then 2, 4, 2, and then 9, 3, and then 16, 4, and then 25, 5, and then 36, 6, and then 49, 7.
It's
Okay? Yeah, we did this picture already.
Jose.
And how do I perform this translation on the graph? Well, every single point along the curve is going to go right 2, up 4. Well, let's just do it for the ones that I have right here. I'm going to go to the right 2, up 4. Boom. This guy is going to go to the right 2, up 4.
Boom.
Boom. Okay, mine's not perfect,
Mine isn't either.
No, I'm
Mine
just
is-
sketching her out, you know?
but
Boom.
It just how does it just stop there?
That's where it starts.
It never
It
stops.
starts there.
The square root function has
Mine's a
restrictions.
little suspicious.
Yeah.
Okay,
It can't go anywhere.
this is g of x,
Why is it climbing?
which is radical x minus 2 plus 4.
Right, too.
Okay,
Why do you choose one?
we're going to talk about domain and range of
It can't
both
go left from
functions.
2.
Correct. For f of x, which was our parent function, our base function, radical x, square root of x, the domain, Are there any values of x that we were not allowed to put in to this blue function?
Negatives. X
No
must be
negatives. I can put
must be
0
greater
in
than
there.
0.
By the way, why can't I put negatives in there?
Because it doesn't let
You
You
can't
can't
have
square
a
root of
negative.
zero.
No such thing as the square root of a negative number. Okay? So this is x belongs to the set of real numbers
No negatives.
such that x is greater than or equal to 0.
Yeah, I said that.
What is the range of the original function?
X is
Y.
Y.
Y comes from the set of real numbers. Any restrictions on y?
0 must be greater than 0.
It also must be greater than or equal to 0.
Yeah.
Okay, you can't, I mean, if you're not going to put a positive and negative in, you can't get a negative out.
What about the new?
Alright, let's talk about the new one.
No, not done.
For g of x, which is radical x minus 2 plus 4, you can do a couple things. You can look at the graph to get it, or you can say, okay, what did we do to every single value of x? Well, you said we moved it to the right 2 units. So my furthest left unit, which was 0, 0, x coordinate of 0, got moved over 2.
So 2.
I can't go left from 2.
Cannot,
So
X
x
not
belongs to the set
equal
of real
to
numbers.
2.
X is greater than or equal to 2. Range. Easiest way to get range is 9 times out of 10 going to be just looking at the picture. Okay, in this case we have our original range, which was y belongs to the set of real numbers. Y must be greater than or equal to 0. And what did we do? We moved every single point on the curve up 4.
Greater
So
or equal to 4.
y must be greater than or equal to 4. Ladies and gentlemen, that is a wrap up for lesson 2.3. You now have a ton of experience and information on
That was
transformations,
the easiest one.
particularly horizontal and vertical translations. Practice problems that you're responsible for are on the bottom of the page. They come from page 102, numbers 1 through 8 and 11.
That was the easiest lesson so far.